Now, when we declare an array, as we have done here, this is one of two popular styles in which we declare arrays. The first type is where we give a type specifier, like we have char over here. We can give another type, like let us say int or float or double. Then we give the name of our array. In this case, I have chosen the name s1. And then inside square brackets, we can put a number, how big of an array we want. Notice that in this syntax, I don't have an assignment statement where I have initialized the values in that array. So this would only declare the array. It would simply create a box that is suitably large, capable of holding a certain number of items of this type. Please remember that arrays in C are of a fixed or homogeneous type. So when we give it the size, the C compiler knows how much memory to allocate, how much memory this box will actually take. So now a question that might appear in your mind is, how does Python do it? How does Python know how much memory to allocate for a list? Do you see that as we explore the C programming language and understand a little bit more about what is actually happening deep inside the computer, we start getting doubts about how Python actually works. How it works starts seeming very mysterious to us, even though by this stage we had learned some sort of a mental model that we were getting comfortable with. Well, now we are going to try and demystify some of these aspects of Python, but for that we need to learn a little more. So this is one style in which I could declare an array. The other style, which you see over here, is where I give the type, I give the name, and I don't put a number inside the square brackets, and I simply initialize it with some value. Now, exactly how I specify the value will depend on the type. In the case of strings, I just indicate the value inside double quotes, and these individual letters will be copied over into the array. But at this point, our friend has a very important observation. You see, our friend looks at this and says, look, the length of the string color, at least if you think of it in Python terms, well, that is 5. And even if you think of it in just regular English terms, the spelling of the American form of color has only 5 letters in it. So why is this array of size 6? Notice that it starts at index 0 and it goes up to and including index 5. So that is an array of length 6. So why is it that the compiler chose to allocate 6 characters when apparently we only need 5? Another way of saying this is, our friend wants to change line 2 to look like this. They want to specify the size, which by the way is legal syntax. But our friend is saying 5 should be enough. Why do we need 6? Well, the compiler isn't stupid. The compiler knows that a string of length 5 requires 6 characters. And those 6 characters are the 5 characters of the string, followed by a special character \0. Remember, backslash is an escape symbol. So \0 is not the letter 0, it's a special value. It is the null character. And this is why we say that C strings are null terminated arrays of characters. So if you want to find the length of a C string, you have to start at the beginning and count until you see this special null character. And that will tell you that the length of this string is C. By the way, what exactly do we mean by the beginning of the array? Well, the beginning of the array is also called its base address. That is the location in memory at which the value at index 0 is stored. The value at index 1 is stored immediately after that, and the value at index 2 is stored immediately after that. That is to say that all the items in an array are contiguous in memory. They are next to each other in memory. This is why, given any index, you can calculate its location in a fixed amount of time. It's a simple mathematical calculation involving the base address and the given index. And one more piece of information: how big each of these little boxes is. It turns out that characters, for example, are typically 1 byte in size, whereas things like integers and floats and doubles typically occupy more bytes. Doubles, in fact, occupy twice as many bytes as floats. This is why double is also called double precision and float is called single precision. So the meaning of this syntax, s1 is equal to the string color, is really saying first initialize a contiguous chunk of memory, like the compiler has done here, at some base address a. The compiler says, I don't mind where that address is, but just initialize this chunk of memory at that address. And now I'm going to call that address s1. So s1 is actually just the location in memory where the letter little c is. Next to that location is the letter little o, and so on, all the way up to the null character. And once we hit the null character, we don't look beyond this. There will be something else beyond this, as long as the computer has more RAM, but the null character represents the end of the string. So this is what the first way of representing strings in C looks like. We typically don't manually specify the length of the string. We let the compiler figure this out. If we do it manually, we must remember to count one more for the null character. This is often a mistake that humans make, so it's much safer to just leave the value unspecified. If you do leave the value unspecified, you must provide a value over here. You cannot simply declare a string of an unspecified length.